Hello everybody, my student ID number is 10506965. And so today I'm going to be taking you through the Internet Control Message Protocol, ICMP. Okay, to start off, we'll have a brief introduction. The movement of data in a network can be represented as layers on the two models, the OSI model or the TCP/IP model. The OSI model has 7 layers, whereas the TCP/IP model has 4 layers. The Internet Control Message Protocol, which I shall now be calling ICMP, lays in the Internet layer of the TCP/IP group of protocols, or we can say the TCP/IP stack. Okay, what is a protocol? I think most of you have heard of the word protocol being mentioned, such as government protocol or diplomatic protocol. This really means the set of rules or guidelines that have to be used when dealing with government affairs. So in the same way, people must have a set of rules and guidelines that govern their communication. And this is called a language, for example, English. So likewise, computers also require a set of rules and guidelines to govern their communication, which brings about protocols. And of particular interest today is ICMP. I shall now show you the ICMP protocol on the TCP/IP stack. So this is our ICMP protocol right there on the internet layer of the TCP/IP model. Okay, I'm going to call ICMP the "Are You There" protocol. Some would want to call it the nagging protocol. In essence, ICMP is used by devices on the internet layer, for example, routers and hosts, to communicate with each other. There are many different types of messages used in the ICMP protocol. For instance, status messages, example ICMP echo and ICMP echo reply messages known as ping. We've got status messages, example destination unreachable message. We've got control messages such as the ICMP redirect message. To mention some of the popular ones. So now, this is a list of the ICMP messages right there. And that's your ICMP header with the type, the code, and the checksum, and other message specific information. Okay, so we're now going to demonstrate ICMP. We're going to go to our command prompt window and we're going to ping, which is one of the ICMP types of messages. Okay, so we sent 4 packets of data and we received 4, which means 0 were lost. And the time to leave was 128, and each packet is 32 bytes. And that's our IP address right over there. Okay, so now let's go to Wireshark and see. As you can see right over there, that's our ICMP packet, and that's our message right over there. Destination unreachable, port unreachable. Okay, so as I mentioned earlier, that's one of the types of messages that you can find on the ICMP set of messages. Okay, we're now going to look at some of the messages that of significance or commonly experienced in the ICMP protocol. We've got type 4, which is called the source quench, or type 30, which is called the trace route. A source quench message appears when a router is telling a host to reduce the rate at which it's sending packets. It's simply saying, please stop bombarding me. Please slow down. So attackers take advantage of this feature, and knowing your IP address, they will ping vulnerable hosts till they are, well, dead. This is called the ping of death. And if you're a network administrator, you would have to protect your network through the use of firewalls and intrusion detection systems. Okay, and let's look at traceroute. Well, traceroute allows you to follow the path taken by a packet around the network. So an ICMP, echo is released into the network, and its time to live is set at 0. When it gets to the first router, the one value is set to 0. So as the echo message is consistently sent and the values are set up, the packets will keep going on and on into the network, and every router that they experience will set their time to live to 0. And this message is sent back to the source. And as you go, you will manage to get information on the routers along the route to the host. And subsequently, the route that is taken by the packet along the network. So thank you, everybody. This is the end of my presentation.